welcome to our first online class for Algebra 1. Should be section 8.2. I'm thinking this is March 24th. Yesterday you should have done function factoring review worksheets. And today we're moving on lesson 8.2, which was working with graphing parabola quadratic equations in form. What we did in 8.1 before break, standard form of a quadratic function looks like ax squared plus bx plus c, where a is not equal to 0 because I need that x squared term. That's what makes it a quadratic equation. The parent function in its simplest form, that's what a parent function is, looks like f of x equals x squared. The shape's a parabola. The minimum was the lowest point on that parabola if it opened up. The maximum was the highest point, and these were called, the point is called the vertex. Every parabola has an axis of symmetry, which is a vertical line passing right through the middle, so it's symmetric on either side of that axis of symmetry. We talked about a, f of x, being the vertical stretch, so that that parabola is narrower, so it needs to be stretched, if a is greater than 1. We talked about a vertical shrink, which makes that parabola wider, if that absolute value of that leading coefficient is between 0 and 1. If a is positive, that leading coefficient is positive, then the parabola opens up. If a was negative, then that parabola opens down. If, for the parent function, the axis of symmetry was x equals 0, so the y-axis was the axis of symmetry, and the vertex was the origin, 0, 0. Remember that we read graphs from left to right. So even though these arrows are pointing up, these values are decreasing as x approaches negative infinity, and they increase as x values approach positive infinity. Look in your book at the beginning of page 426, and we are talking about ax squared plus c. If you remember in transformations, plus c, so I have a function and I'm adding a value to that whole function, was a vertical translation. So I'm moving up c units if c is positive. I'm moving down c units if it's negative. If you look at the picture in core concepts, the green line was where c is positive, so I'm shifting it up. The blue line was the parent function, and the red line is a shift down, c units. If you graph, example 1, x squared minus 2, if you look at that equation, already you know what's going to happen. That parent function that was centered at the origin is going to move down 2 units. And your book can put points in. If you were doing this by hand, notice that it's symmetric. So the y values, the g of x values, for negative 2 and positive 2 are the same. The y values for negative 1 and positive 1 are the same. And 0, negative 2 was that vertex. So that vertex that was at 0, 0 has been shifted down 2 places and is now 0, 2. If you look at the graph where they work that out, you can easily see that. Look at monitoring progress. What happens with 1? Hopefully you notice that it is shifted down 5 units. So its new vertex is going to be 0, negative 5. And if you look at monitoring progress number 2, where g of h of x is shifted x squared plus 3, that vertex is now located at 0, 3 because instead of 0, 0. It's been shifted up 3 units. If I'm looking at example number 2, this is on page 427, and you're graphing 4x squared plus 1, comparing that to the graph of x squared, what do you think happened? The 4 means that that parabola was made narrower, vertically stretched by a factor of 4, and shifted up 1 unit. If you look at the graph to the left of that, the black one is the parent function, f of x equals x squared, and the blue points are where the transformed parabola g of x. Example 3, yours another one, only this time we're moving the whole, we have two functions, so f of x this time is no longer the parent function. It was defined to be negative 0.5 x squared plus 2. And g of x was to be f of x minus 7. That means that this function is going to be transformed by shifting it down 7 points, 7 places, 7 units. Part A said describe the transformation and graph them in the same coordinate plane. In your calculator, if you would go to y sub 1 and enter the parent function, f of x equals x squared, or y equals x squared, so y sub 1 x squared, and y sub 2, actually, let me change that. Y sub 1 is going to be this parent function, so negative 0.5 x squared plus 2, and enter y sub 2 as negative 0.5 x squared plus 2 minus 7. And then what happens when you do this? F of x, I'm just subtracting 7 from this first one, so I could rewrite this as g of x is going to be negative 0.5 x squared minus 5. And enter that as y sub 3 these two should be identical and should be 5 units down from where, or remember this is reflective, so my parent function is going to be at 2, so I have a vertex up here at 2, and this one would be at negative 5. Double check on your calculator. When you finish, you could pause this, do it, and when you come back, look at monitoring progress. What's going to happen with number 3? G of x equals 2x squared minus 5. Compare that to the parent function. Hopefully we can see that it's going to be narrower because of the 2, and it's going to be shifted down 5 units, because of the negative 5. Look at 4. It's going to be reflected because of the negative sign that's in that leading coefficient. It's going to be stretched or shrunk. It's going to be shrunk by a factor of 1/4. That means it's going to be made wider, and it's going to be shifted up because of the plus 4. For example 5, if you had worked that out, I hope you paused and did that. So look at G. A, describe the transformation from F to G. What happened? Right, you're going to take that function and move it up 3 units. And if you wrote an equation to do that, you would have written, the one that you started with was 3x squared minus 1. To that, you were going to add 3. So when you finished your new equation, 3x squared minus plus 2 is your new g of x. Turn the page and look at our favorite word problems. The way to make these easier is to read them carefully and look at what they're telling you. So, have a little picture before we do that. Zeros vocabulary. I have a 0 function. I have x-intercepts. And we have roots or solutions. When we talk about equations, we talk about roots or solutions. When we talk about graphs, we talk about x-intercepts. And when we talk about functions, we talk about zeros of a function. Zeros are the x value of that function, or the value of the variable, that makes that equation, that function equal to 0. When I graph that function, those values are where it crosses the x-axis, so they are the x-intercepts. And when I solve that equation algebraically, those values are the roots or solutions of that equation. We call them different things when we talk about functions, graphs, or equations, but they all represent the same numbers. If I'm looking at now, example 4, solving a real life problem, they gave you a function that was describing the approximate height in feet of a falling object. So it was f of t equals negative 16 t squared plus something they called s of 0, which was the height, the initial height in feet. Then they drop an egg from the top of that building, 64 feet, and want to know how many seconds does it take for it to hit the ground. So things to think about in this equation. We know the initial height was 64 feet, so into this equation we replace s of 0 was 64, and this is the height after t seconds. So when it hits the ground, what's the height? 0. So we replace it with 0. In your book, they graph, they make a table of values to look and see, and they graph those values, and it's like half of the parabola. If you solve this algebraically, the first thing I would want you to do is take out the negative and the 16, because those are negative because we never want to make leading negative, and the 16 because that's our GCF. And so you would be left with t squared minus, because remember you factored out that negative, minus 4. If you factored that to find the roots of that equation, I would have t minus 2, t plus 2, and that means your time, because that's what t is plus or minus 2 seconds. Does negative seconds make sense? No. No such thing as negative time. And so time t equals 2, and that's what they're showing on the graph. Notice the other thing they're pointing out is that is not the way the egg falls. They're just showing you that's the height at some time. Your x-axis is the time in seconds, and y was the height in feet. Look at monitoring progress. Well, 6 we've already talked about, so hopefully we know we're not using negative values because negative time makes no sense. And if we're looking at 7, plug it in, try it, pause, see what you get. I hope your answer was 2.5 seconds. This completes the lecture for 8.2. Your homework for this lesson is on the board. It is in your textbook. Those problems are 1, 2 through 26 even, 27 through 30, 34 through 38 even, and 42 through 45. I hope that watching the video and doing those problems doesn't take long. This is an experiment in progress. We'll see what happens. These are due, so mandated, by 9 p.m. March 24th, because that's the day that I think you're watching this video. I'll see you later.